Thank you, and good afternoon. So I think one of the benefits of speaking in the afternoon is that a lot of the topics have already been covered, and you might even recognise some of the images in my slide from both Aideen and from Paddy's presentations earlier on, but hopefully we'll be bringing something new to that and building on what both Martin and John had discussed earlier on in terms of certification and our experience coming from a design certifier point of view. So we're going to talk through our own experiences of it, the benefits and challenges of MMC from what we've found from a design perspective, site considerations. I'll talk through a case study in the form of Tallaght Innovation Square Apartments, which has recently been completed, and the kind of compliance issues that we had there, certification issues. And if we have time at the end, I'll run through a few other projects as well that we have currently on our books that are utilising MMC in various different forms. So who we are, first of all, just to give you a bit of a background about COADY Architects. We're over 70 staff in total. We're based across 3 different offices, 2 in Dublin, 1 in Galway. We have 3 directors, 4 associate directors and 12 associates. And so, as I said, staff spread across the country. Our experience is kind of broadly based on housing, student accommodation, healthcare. So firstly, looking at some of our housing projects, we do large-scale social housing, private developer-led housing. We have a lot of student accommodation as well. And the reason I'll give you a quick overview of these projects, just very high level, and hopefully touch on some of the areas that we are using MMC within those projects now. Office projects then, so we do a lot of office fit out, or we had done a lot of office fit out pre-COVID, and then we have a lot of office shell and core buildings, so we are involved in the Limerick 2030 project and Project Opera, and then you can see 2 other images there of the DAC buildings in Dublin Airport, which we're involved with on the delivery side. Wellbeing, so our healthcare projects are kind of covering all bases within the healthcare side. So we've got nursing homes, we have primary care centres, we delivered the 2 children's hospital wings in both Tallaght and Blanchardstown. So we have a broad base of experience there on healthcare. And then education as well, so we do everything from primary to 3rd level, and we have kind of experience with MMC and that as well, which we'll touch on. We're also partnered up with a number of European and UK-based practices under our Perspective brand, so that gives us an insight into their learnings within Europe and kind of sharing knowledge and indeed kind of working together on projects. So our own experience, and I think we touched on it a couple of times earlier on in terms of the categories of MMC. So our main experience would be in categories 1, 2, 3, and 5. And in the case study, it would be largely, that I'm going to talk through, would be largely precast concrete panels. But we do a lot of 3D volumetric, we have done housing, and schools as well. Why MMC? So I know this was touched on earlier on, but just to kind of broadly brush over it and to kind of touch on one item that some people kind of say, well, how is that affected? The diversity and inclusion side of it, and I think it was touched on earlier on. One thing we've noticed is a large uptake of women working in the factories in terms of construction compared to on-site construction. We've also found that people are more, they prefer to be kind of factory-based rather than moving around the country, not knowing where the next project is going to be. So it does open the door to a lot more people who might not necessarily stay in the industry because of the kind of site involvement that would be needed. So the program benefits of MMC. So the graph there kind of speaks for itself. It's not taking away, from a design perspective, it's not taking away any of the tasks that we do. You can see there, just within a more confined program period, we are front-loading the work and kind of getting it ready for the off-site manufacture, whereas the traditional construction method would be a lot more linear in terms of how we deliver our information, how the information is received, and how we receive information back in there. So what we found is a large buy-in is needed early on in the project. That comes from across the design team, across the construction team, and the client team. And so that includes the assigned certifier, and an understanding that front-loading this project, answering the questions early, answering the tech subs early, getting it all turned around quite quickly, leads to a much shorter, or can lead to, I should say, a much shorter program on site, and a much more efficient program. We'll kind of touch on that as I move through the case study. Sustainability. So I think it might have been on Paddy's presentation. He had a similar graph there in terms of the embodied carbon energy. So I won't dwell too much on that, but we have also noticed decreased amount of waste on site, increased quality control, and a reduction in the transport and carbon footprint of some of our LGS panels that are being constructed. Challenges then, cost. So the efficiency of cost is still being looked at. Obviously, mass production, the larger the amount that is being produced, the lower the cost is going to be overall. The design requires repetition. And what you'll see with the Tallaght case study that I'm going to talk through, there is a lot of repetition. That doesn't necessarily mean the design has to be one big block that looks very boring. You know, it's about kind of incorporating that repetition into your design, but maintaining the standard of design that you want to deliver. Certification, which has been touched on a good bit earlier on, and we will discuss that with the Tallaght case study. The site and storage capacity. I'll give an overview of the site context in Tallaght. It was considered a tight site by the contractor from the purpose of storing the precast panels that were being used on site. And then I think what a lot of the discussion earlier on was about as well was the quality of joining any panels together or volumetric 3D buildings together. So how they are joined together on site is where they can fail. So we'll take a look at that too. So you might recognize the image on top there from Aidan's slide as well. Aidan came out and visited Tallaght a number of months ago for a walk around prior to its completion. So Tallaght was 133, that says bed spaces, it should be apartments, that we designed and delivered for South Dublin County Council. It was completed at the end of last year. It was due for completion, I think, towards the end of this month, so it has finished early, and I'll kind of talk about that. But it was a 23-month program, and it finished in just under 18 months. So quite amount shaved off that, a lot of that down to the nature of the precast panels being used. So it's a 7-story building with, as I said, 1, 2, and 3 bedroom apartments, and one block, as you see on the bottom left image there, which are what we were calling duplexes. They're not duplexes, they are in fact townhouses. And then there's a central podium between all the blocks, which links it together, which is a communal kind of courtyard space with playground, vegetable patch area, barbecue area for residents, kind of just the communal open space that is required. Underneath that then you've got your car park and your bike storage and plant rooms. And we'll touch on why that's relevant as I work through the images now. So just to give a bit of context, for those familiar with Tallaght, the Innovation Square is a new development, a new civic plaza that's created just to the north of the County Hall building. And it is slightly to the east of Tallaght Hospital. So the road that you can see, the Cookstown Road that's running down there, has now been extended and runs right the way down to that icon that says number 6 at the bottom. And we are number 1 there with the red outline. Number 2 on the image is the civic open square there with kind of landscaped green space. And then there's also a communal work hub that opened up recently as well. So it's quite a centrally located site. but quite a tight site, as you can see there, given the size and scale of the building that we were fitting onto it. So it's a brownfield site. It also forms part of a new greenway that links through the site. So as part of the development was to deliver this greenway within the site confines. So that links Tallaght IT, or TUD Tallaght, to the hospital and onto the other kind of greenway networks. So within the design considerations, there's a move left principle that needs to be adopted and needs to be kind of embraced. The graph you see on the right there was actually taken from a CISC presentation on MMC that I attended a number of months ago. And I think it's really kind of telling in how that move left principle can be applied. So the line at the bottom there, and you'll have to excuse my colours if I get them wrong because I am colourblind, but I think it might be red, that goes up is your cost as the stages progress through the RAI stages from 0 to 8. The other two lines that are curving down are material optioneering. So the options to change things and the options to change your designs and the impact of that design change that can have. And as you see, there's more of an opportunity to do that obviously early on, while the cost is still low before that cost rises up as the progresses through its various stages. Really basic, I know, but you'd be surprised at how impactful that is when all those design changes, all those considerations are taken into account quite early on. And then when it gets to site then, so in Tallaght, let's say, there was one claim on site, which was for a one missed connection on an AOV or something. Other than that, there was no changes on site once we got to site. Nothing was unresolved. So that did, as I said, require a lot of buy-in from the design team. The other consideration that you need to look at is repetition. So what we tried to do in Tallaght was minimize the apartment typologies that we had. So obviously, what we don't want to create are just these large kind of blocks of repetition, but we did manage to use the typologies that we already have in the COADY library, shall we say, which are based on the design standards that we've developed over the last 10 years. We know what works in terms of apartment layouts. We know how they kind of react, how they are to live in them. What we're now trying to do is adapt them, and that's our challenge at the minute, is to adapt them into MMC, to get them into sizes that work if they're going to be panelized, or however we want to kind of progress that from an MMC point of view in terms of module size. The other thing that you need to be considerate of are the space planning. If we were looking initially at kind of creating more 3D volumetric sizes, and I will show how we've done that kind of diagrammatically later on in the presentation. Junctions of the building fabric, so that is really where this kind of, the method of construction here that we used, which was precast architectural wall panels, came into effect. The cores, how we're treating them, so in this instance, it was in situ concrete cores. Heights allow for the build-up of combined base and roof cassettes in 3D volumetric. So that wasn't really applicable on this project as it turned out, but I will show where that was the case. And module sizes. So again, module sizes relating to the overall apartment size, if you were to break it down into what can fit on the back of a lorry. So as I said there, we've got 3 blocks essentially in Tallaght, connected with a podium level at first floor. So block A on the left and block B on the right, with block C, which are the townhouses down the bottom in the middle. So the repetition there starts from first floor up to 7th. So those repetitive apartment typologies kind of are stacked. So that repetition allowed, the same panels be manufactured. The repetition allowed the same balconies be manufactured, and also bathroom pods. So what we did was we looked at our layouts and said, well, how can we reduce this down to having 2 bathroom types? We've got the main bathroom and the ensuite typology, and also with our balcony sizes. So how could we reduce down the typologies of balconies? So we only had, I think, 2 in the end on this project, 1 to suit both sizes of apartments that we would need. The balconies were pre-manufactured off-site and just lifted in. The connections, and you'll see in the photographs, were already precast into the precast wall panels. And then the pods were lifted on site as each floor progressed up. So again, there you've just got the simple form, 2 parallel blocks, 10 units per floor, and it's, this is also a non-sprinklered complex. So I know with the LDA apartment typologies that they have now in their booklet, the preferred option is to go with a sprinklered typology, which wouldn't have, let's say, a hallway when you walk into it. So we had that hallway still. It was a non-sprinklered one. The other interesting element of this project is, and it's not necessarily MMC related, but it was connected into the Tallaght district heating scheme. So it was taking excess heat from the local data center and kind of bringing that in and using it for space and water heating in the apartments. So from the outset, the design and the kind of criteria that were set out by South Dublin County Council for it to be a low carbon building, and the design intent, it needed to be maintained no matter what route we went down with MMC. So our role in COADY is we were novated to the contractor. So we took it through design under contract with South Dublin County Council up until planning and tender. And then from construction, we were novated to the main contractor. And at that point, it was kind of up to them as to how they wanted to interpret our design. Our design we had intended it to lend itself to MMC in whatever form that might be. So early on, as soon as the contractor was appointed, we were engaging with them, we sat down with them, we had workshops, and their preferred option was to go with an architectural wall panel, precast architectural wall panel system. So the initial question that we had was, well, certification, NSAI certification, is it there? What do we have? And also finishing. Our big kind of concern was around finishing and maintaining the design intent. Someone mentioned earlier on, we don't want this building to look like a modular or prefabricated building. The design intent was for a large brick facade. So we were promised kind of from the outset that the design intent could be maintained. So as I said, the elements that we had there were the prefabricated balconies, the bathroom pods, and the precast walls. So the precast wall in question was, you can see there on the left-hand image there, we have the structural leaf on the right-hand side, which was, I think, 200 mil of concrete. We've got about 200 mil of rigid insulation, non-combustible, and then a non-structural external leaf, which was concrete, precast concrete, which was poured on top of the brick slip faces. So these are brick slips that we had selected as a standard brick, and then they just cut them down or made them to the correct size to be worked as brick slips. Site and construction considerations. So obviously what we were talking about earlier on, and was mentioned a few times in terms of storage. This site, while I thought it had ample space, really the only space to store panels was at the podium space in between the two blocks. So they had a rack system set up, 2 tower cranes to lift panels in, and they were stored on site then for the period. None of them were ever sitting around at ground floor for very long before they were lifted on. I have to say that the contractor was extremely diligent in their program. Any concerns of being kind of rained off or too high a wind for lifting things on was never really kind of came to pass. The one thing we did find was, and the one thing that we had an issue with, was the waterproofing of the system itself when it was on site. So it had been exposed initially on the first few panels that arrived in with the insulation exposed, and we said, well, we're not accepting that. It needs to be fully wrapped up until it's ready to be installed, and even at that point, we only want the waterproof membrane to be removed when it's fully sealed up. So they took it on board. It was kind of lessons learned for everyone, and everyone kind of progressed on in that vein. So building regulation compliance. So early on, we had engagement from the assigned certifier from the builder, from us as design certifier, and how we were going to get this across the line and where we're going to accept it. So there was no Agremont cert for the precast panel in question. And it is, I understand, still in progress. And kind of what Martin was talking about earlier and what John was mentioning, the due diligence then that is required to kind of get that over the line, to look at all those components and to understand the testing that had been done was rigorous, to say the least. So we had a very thorough kind of technical submittal process from early on in terms of looking at pull-out testing, on-site inspections, and as I said, continued reporting of everything that was being done. The QR codes were available for us to check for anything that was delivered to site, and we could check the reports on that as well. So everything, all components had a CE marking and a DOP for every single component that made up the panel itself. It was just the overall panel that was still awaiting NSAI certification. So really from a Part B perspective, again, we had the fire consultant involved, everyone visited the site, satisfied themselves that all elements of Part B were being achieved and there was no issues around that. Ultimately, moving to a precast system didn't have any impact on our granted fire cert. Part D was the big thing really from a building control perspective in terms of workmanship. And the one thing I would say about it is, obviously, off-site construction does allow itself a better quality of finish, is what we had found, particularly when it came to things like the brickwork. And we had brick detailing in there that we wanted to maintain in terms of the Flemish bond and the rebated bricks that we wanted to create a feature, so it wasn't just one big blank facade of brick. And all of that was achieved in a factory setting, and there was no limitations to maintaining the design intent that we initially had. The windows and the sills were all installed off-site, and the steel stubs for the balconies, as I said, were cast into the panels before they came to site as well. So when the balconies came at the kind of 12th hour of construction, they were lifted in by the crane as needed. The move towards this also meant that there was no scaffold throughout the construction. And I might trip myself up because I think there is one image with a scaffold, but it was only to get access up in through a balcony at the 7th floor, I think, as a loading bay. But generally, from a safety point of view, the safety standards on site were increased massively by moving along with this precast system. So, sorry, just touched on that there. Yeah, so this is more has to do with a health and safety side of things, but we had the precast stair giving access, safe access throughout the whole height of the building as the building progressed up. So there was a lower risk. I shouldn't say it didn't mitigate the risk, but it did lower the risk of working at height. There was also a reduction in noise and dust emissions and minimized site waste production. And certainly it was a clean and orderly site when we were there. And certainly you can see from the images there of the factory visits, they were very, very clean. In terms of compliance with Part F and Part L, again, these are tests that we kind of looked for, but were provided instantly. The manufacturer knew what we wanted from the outset. The testing was quite thorough. There was thermal modeling undertaken of all junctions. So we had accurate FRSI's figures given. I can't remember them off the top of my head, but very low U values that were tested and proven. And then the airtightness as well. So airtight tape was actually, I think, mostly just applied on site once the panels were installed, even though the windows were installed at a factory setting. In one instance, the airtight tape had been missed from the base of a window, and we knew that that had happened, and the airtight testing was being undertaken that day, and it still passed and exceeded any airtight test requirements that we were looking for. Ultimately, we said, you still have to go back in and put in the tape, but I suppose what this showed was that the manufacturing process itself had reduced down air leakage, and the panels were quite airtight, almost to a passive standard, if you're looking at it from that perspective. From a sustainability point of view then, we're conscious that precast panels, they do have a high carbon content. We have looked at speaking to suppliers about using GGBS within their concrete mix as an alternative. However, what we've found is that there's a reluctance to move towards that, given the curing time and the impact that that would have on programs and delivery to site. We could have increased our renewables on this project. There was a series of roofs there that we had that could have taken more PV panels, but ultimately we only wanted the PVs, or they were only needed for the landlord areas, so they just served the kind of communal and landlord areas. And you can see there then on the bottom left, that is the heat exchanger for the incoming district heat pipe, taking the excess heat from the local data center. So there was a lot of coordination there as well. And again, this all had to be coordinated early on in the process, and any changes or any moves that we went towards MMC needed to incorporate the requirements of fitting in with the district heating system. The construction couldn't be compromised as a result of that. So our outcomes were the omission of scaffolding and the traditional bricklaying, and it wasn't quite the omission of traditional bricklaying, which I'll touch on now in a second as I go through some photographs. The high quality finish. So as I said, we use bathroom pods, and I think the benefit of having off-site tiling done, let's say for instance, you've got tiling done in a factory setting where you have full lighting and a kind of clean environment, rather than a tiler in trying to fix tiles onto a wall when you've got a plumber coming in to fix something after, and you've got somebody sweeping out the hallway and people falling over one another. There was definitely a benefit there, and I'd have to say almost zero snags on the incoming bathroom finishes and the pods that were delivered. A 3-month construction program saving on a 21-month program, I think it is off the top of my head, which is impressive, and that did not come at the cost of any quality, I have to say. And really that came down to discussions being held early on the construction stage with the contractor. And yes, we were novated across to them, but they kind of said, look, we are front loading this project. We want the information early. We will give you what you need early, but we need responses back early. It's going to be different, but we need you to embrace it. And it worked very well. There was engagement from all parties across the design team and the assigned certifier to make sure that things were approved and got into manufacture quite early. The collaborative working, as I said, was key to that success. And then the repetition is a positive in design, but it doesn't need to be inhibitive. And I hope some of the photographs that I have now will kind of demonstrate that. The one thing I said there was that it didn't fully mitigate the traditional methods of construction. When we decided to go with the precast construction, it was deemed that the ground floor was not repetitive enough for it to be cost effective, but also to allow construction commence on site and to get things moving. We decided to go with the traditional build from ground to first floor, or to podium level, which is that kind of garden area that we have. And then from there up would be the precast wall panels. So from ground to first was in situ concrete walls with full fill cavity, unfortunately, which I wouldn't tend to go with again, but that was to make up the difference that we needed with the overall wall build-up, and then a full brick outer leaf. So here you can see the podium area, which lent itself to the crane base to bring in the panels. You can see the stubs there already in place with the panels themselves, waiting for the balconies to be installed, and the windows all installed as well. Here we have the balconies over on the right-hand side. So as I said, they were pre-manufactured off-site. They did come with some snags. One of the issues that we had was in the delivery to the site was that we found that they did get damaged. And that seemed to be from when they were strapping them to the transport themselves. So the straps might have been too tight, and it did bend some things out of shape. But overall, just jumping back there, and it's hard to tell from that profile, we staggered windows within the elevation so that it kind of didn't look too repetitive. And I think that kind of is the key to the success of this, and not looking too modular. Just to touch on some of the other kind of projects that we have at the minute on site that are using MMC. So we've got the Ronald McDonald House, which we are delivering. We've taken that from planning through construction. So they are insulated 2D LGS panels with a brick external leaf. So that's currently on site. We have Camross Housing in Sligo, which again is 2D LGS walls, and a block and brick outer leaf. And then we have student accommodation in Galway as well, and that is using precast wall panels, precast structure, and bathroom pods. And then finally, just to touch on some of our residential projects, we do a lot of social housing, and we're involved in some of the social housing bundles that are being rolled out across the country. And the one thing that we are kind of looking at and how we can utilize, as I said, is taking what we have as our design standards, which are kind of industry design standards, but are typologies, and how we can make them usable in a 3D volumetric kind of format. So looking at our sizes, looking at our spans, looking at how the layouts work together. So, you know, breaking up apartments into half and how they would be connected, understanding the implications of that in terms of ceiling to floor finishes and the depth that would be required for a 2-story 3D volumetric configuration, and the impacts of that in terms of requiring longer stairs, and how we would deal with that in the overall layout. But they're things that we are progressing in our office, and we are kind of at a kind of latter stage on some of those projects as well with that. So again, yeah, looking at pod layouts and for kitchens and bathrooms and how they can work best as well. That's it, and I hope to get some questions later on. Okay, thank you.